was developed here as part of a graduate course at our Department of Geography at the University of Hawaii. This paper has been published in the scientific journal Nature as a research article. And although only some of us are going to be able to present the work to you, we are talking on behalf of 11 grad students, 1 postdoc, and 1 other professor that took part on this class. Before we present the results, I want to make a little bit of publicity about my course, of course. This course has been developed with the main intention of exposing grad students to the entire scientific method, everything from developing an idea to collecting, analyzing, and publishing data. What you are about to see are the outputs of this year's course. Some general outline about the presentation. I will be doing the introduction and concluding remarks. The students have been selected to present the different components of the paper, right? So with that being said, for this specific course, what we have done is to develop a new index that allows you to calculate the projected timing of climate departure from recent variability. Basically, what we have found is that under ongoing emissions of greenhouse gases, the Earth's climate by 2047 is going to move beyond any analog that we have seen during the last 150 years. Let me rephrase this. If during the last 150 years you have complained about any kind of extreme weather event, after 2047, that's going to be the norm. Basically, very soon you can be kissing your climate goodbye. Bye-bye climate. And you're going to see how is that we came out to this conclusion. We have come to know that the climate has multiple controls over different things. One of those is biodiversity. We know that indirectly, those effects of the climate on biodiversity can influence people through the delivery of goods and services. We also know that directly the climate influences us. One thing that is happening today is that with our increasing emission of greenhouse gases, the climate is changing. We know that some places are getting warmer, patterns of rainfall are changing, sea level is going up, the oceans are becoming more acidic, and several other climatic responses, changes are happening. The species are tracking those changes. Some species are moving to other places, trying to keep track of more suitable climates somewhere else. Some other species are staying, and they are trying to adapt to these new climates, and sadly, some species are going extinct. Indirectly, this is affecting people. We have come to know as well that as a result of these changes in the climate, people is being affected as well. We have documented several times already that with increasing climate change, there is a faster spread of diseases. Humans are being affected on their health. This is forcing people to move, and it's increasing the tensions as well for violent conflict. As you can see, there is a very strong connections between the climate, biodiversity, and people. Given the strong effect of potential climate change on this, you can see why it's so important for us to understand climate change.
When looking at the rich body of knowledge on future climate change, we find that there's an extensive amount of literature on absolute changes in the climate. That's asking, what is the magnitude of climate change? There are also studies on novel climates, where new climates are likely to emerge by the end of the century, and even groundbreaking research on the velocity and direction of climate change. An aspect of climate change that we don't know much about is the timing. That is to ask, when will climate change result in an environment that is completely different and beyond our past and present experiences? We focused our attention on that question and developed an index to measure the timing of unprecedented climates at any location on Earth. To explain how the index is calculated, we used a grid cell example in Hawaii as a sample cell here. We used the minimum and maximum temperatures over the last 150 years to define the bounds of our historical climate variability. This is shown here in the gray box. We then use model projections for the next 100 years to identify the year that future temperatures will shift outside of the range of this historical precedence. We define that year as the year of climate departure. For this location, 2029 marks the year when temperatures continuously exceed historical bounds. In addition to temperature, on land we calculated our index for precipitation, evaporation, transpiration, and sensible heat flux, and on oceans for sea surface temperatures and surface pH.
Before we go any further, tell you a little bit of the background of where we got the data to calculate our metric. We got the data from something called an Earth system model. An Earth system model mimics the interactions of Earth systems among one another for a particular grid cell, and then through mathematical formulas, those grid cells interact, and you get an idea of, or a projection of the climate for the whole Earth. For our study, we used 39 Earth system models from 21 climate centers located in 12 countries, and basically got a hold of all of the most up-to-date current Earth system model data. The models differ in structure and complexity. However, there are, for this particular set of models, something that was held constant, and that was the emission scenarios. So there are two common emission scenarios. There's the RCP 8.5, which is indicated in the red line here, and that basically says business as usual. We're not going to do anything about what we're currently doing to the atmosphere as far as anthropogenic CO2 emissions. And you can see by the end of the century, we're at a little over 900 parts per million. The other scenario is the RCP 4.5 in the yellow line here, and that says that basically there's a concerted mitigation effort, and we're kind of getting off our asses and doing something about the CO2 in the atmosphere. So to give you put this in perspective, currently we're at about 400 parts per million. So it shows you that regardless, at the end of the century, there's going to be a different composition of CO2 in the atmosphere. Looking at this now in our same grid cell that Lauren presented, you see our past variability defined in this gray box here, and then the two RCP scenarios, the 8.5 and the 4.5, projecting into the future, give us two very different future scenarios. For the RCP 8.5, climate will exceed current variability in 2029, and for 4.5, 2050. So this highlights some kind of important point, is that no matter what we do, we will exceed these current climates regardless of the mitigation scenario.
So what is the timing of climate departure globally? So we determined this for all locations on Earth, and we mapped the year of climate departure under the two different future scenarios. Okay, these maps reveal new spatial patterns of climate change. Under the CO2 mitigation scenario, RCP 4.5, the average location on Earth will experience climate departure by 2069. Under the business as usual RCP 8.5 scenario, the average location on Earth will experience climate departure by 2047. This is just 34 years into the future. The colors on the maps show the year of climate departure, with reds showing years earlier in the century and blues indicating years later in the century. As you can see on both maps, the tropics are experiencing these changes first, as soon as 2020 in some areas under RCP 8.5. This is very important because most of the world's people and biodiversity are concentrated in the tropics, and we will talk more about this shortly. If we look at the RCP 4.5 map, you can see that even with aggressive action taken to reduce our CO2 emissions, most locations on Earth will still experience climate departure before the end of the century. So there are two ways to look at this. We can say that since climate departure is going to happen anyway, why should we bother taking any action now? But there are serious consequences for this, and it means that we are going to be tested very soon, and as you will see throughout this presentation, we do not want that to happen. The more optimistic way to look at this is that if we do start taking action now to reduce our emissions, we will buy ourselves critical time, not just for us, but for species, to try to adapt to these coming changes. So we have made our results available online in the form of an interactive map. So you can go anywhere on Earth and determine the year of climate departure. By clicking on a point on the map, a graph will pop up showing historical and projected temperatures for that location and give you the year of climate departure. So with these maps, people will be able to see how their climate is changing where they live, and this will hopefully help convey the urgency to act.
So why is this important? Our paper brings up some new implications that will significantly add to the climate change conversation and may change the way we think about this subject. First of all, we believe that traditional metrics allow us to have a false sense of security. The current climate discussion mostly focuses on absolute changes. In this map, you can see the areas in red in the higher latitudes that are expected to have the greatest absolute change. If we look at a map of our index, we see something very different. The areas in red in this map are areas that will experience the soonest changes. And compared to the last map, those changes were, the greatest changes were in the higher latitudes, and in our map, we see the soonest changes in the tropics. To assess the correlation between these two indices, we developed a scatter plot in which the year of climate departure is for a given location on Earth is on the x-axis, and the corresponding absolute change for that same location is on the y-axis. If the areas that are experiencing the largest absolute change are also experiencing the soonest changes, we'd expect to see a strong inverse correlation that looks something like that. The actual pattern is something quite different. This is a density scatter plot in which the areas in red indicate the highest density of points. There is no significant correlation here. The highest density of points is located in the bottom left, which indicates the areas of smallest absolute change will actually be experiencing the soonest climate departure. And these areas occur in the tropics, where small changes can be detrimental given the small historic climate variability. Second, our paper highlights that major changes have already occurred. As mentioned previously, in addition to temperature, we looked at sea surface temperature, ocean pH, transpiration, evaporation, precipitation, and sensible heat flux. And if we look at this map of the ocean pH, we see that the entire map is red. And this indicates to us that pH moved below historical variability in 2008. And that makes sense because the oceans have been absorbing much of the CO2 emissions since the Industrial Revolution. Evidence of ocean acidification has been broadly reported in several marine organisms, including corals.
The third implication is that there is poor socioeconomic capacity to adapt to these future climate changes. We took data on our index and compared it to the distribution of human populations worldwide. And we made a graph. We have year of climate departure along the x-axis and the cumulative global population along the y-axis. And what we found is that 1 billion people under a mitigation scenario, or RCP 4.5, and 5 billion people under a business as usual scenario, or RCP 8.5, currently live in areas that will face an unprecedented climate by the year 2050. To gain additional insight into the vulnerability of societies in these areas, we looked at data on gross domestic product. As you can see from this graph in the lower right, we have gross domestic product along the x-axis and the year of climate departure along the y-axis. And there's a positive relationship under both scenarios. So this means that developing countries, or countries with low gross domestic product, will be the first to face unprecedented climates. In other words, the countries that are first impacted may have the least economic capacity to respond. Finally, the Earth's biological assets are at stake. We looked at data on our index. And compared it to the distribution of several species. We looked at around 344,000 species globally. And as you can see here, the areas that indicate high levels of biodiversity, those areas are in red and yellow. And you can see that those areas of high biodiversity are located in the tropics. And this pattern extends through several taxa, ranging from marine and terrestrial vertebrates, invertebrates, and plants. When we compared the global mean of the timing of unprecedented climates under RCP 8.5 and RCP 4.5 to the timing of unprecedented climates for areas with high levels of biodiversity, we found that on average it was 10 years earlier. So here, the black lines in the middle, those indicate the global means, and the horizontal blue and green bars, those indicate the timing of unprecedented climates for these different species groups. And as you can see from the graph, for most of those bars, they're to the left of the global mean. So this indicates for areas with really high levels of biodiversity, we're seeing earlier emergence of unprecedented climates. Given that most of the Earth species occur in the tropics, and that the emergence of unprecedented climates also occurs in this region, and that species in the tropics are vulnerable to small climate changes because of their narrow climate bounds, means that the Earth's biological assets are at risk.
Okay, our paper has established that there will be a large number of species and people that will soon be facing unprecedented climates. However, it's fair to ask the question, are these species or people going to be impacted? As a scientist, for us, it's very hard to predict specific responses. The reason for this is the complexity of these biological, social, and climatic systems. However, that doesn't prevent us of making general predictions about what's going to happen. In fact, we can actually predict that there could be massive consequences from these changes. This is our argument for this. In our very recent past, we have had some minor, very sporadic extreme climatic events. In response to this, we have found that species, some of them had moved their geographical distributions to other places, some of them had adapted to these changes, some species had gone extinct locally, and many had faced massive die-offs. In turn, we had impaired the capacity of these biological systems to deliver goods and services, and this has resulted also in human consequences. We also know that these oscillations, very sporadic, of the climate had also affected people directly. We had data already documenting some consequences, including heat, stress, mortality, violent conflict, reduction of labor productivity as well. These are just some of the consequences from very sporadic extreme climatic events. What we are talking about here on this paper is a situation in which these emissions of greenhouse gases are going to make these extreme events the norm after 2047. So you can truly predict that there will be some massive consequences from facing these unprecedented climates. As a scientist, we are forced to narrow our focus on the things that we do. As a result of this, one of the things that happens is that we fail to see the broader implications of the things of our work. One of the things that is happening right now for our generation is that we are witnessing this massive deterioration of our biological assets. This is happening as a result of habitat loss, overexploitation, invasive species, and now add to this list this massive assault from climate change. One of the things that is happening as a result of this thing is that species, they don't want to go extinct. They are trying to adapt to these new stressors, and as a result of these adaptations, what is happening is that they are losing genetic diversity and their capacity to go back to the original states. These biological characteristics make these stressors very worrisome. The reason being that these changes that we are seeing could be irreversible. These could affect the delivery of goods and services, and ultimately it could affect people. Today, at the global scale, we have 1 billion people going hungry every day. Listen to this, 1 billion people going hungry every day. You have to wonder, how are we going to improve the quality of life of these people when our eagerness to develop is triggering this vicious cycle of negative biological and social impacts. In my opinion, there is a much bigger reason for us to care and act on this right now. As a result of our exploration of the universe, we have come to know that there are quite a few 100 billion planets on the universe, of which only a handful of them have the characteristics of planet Earth. We are talking about the fact that the probability of us of finding another planet like ours are about 1 in 1 billion. Let me tell you how rare this is. This is like winning the national lottery 5 times in a row. Does anyone here knows anyone who has won the national lottery at least once? Please don't tell me that you did. Good. So now imagine what it will be to win the national lottery 5 times in a row. That's how rare our planet is. Now, what we are talking about in this specific paper is a new stressor that has the potential of changing not only climatic, but also biological and social systems. It could break it. The loneliness of the universe, what that means is that we will be stuck on this system. We will be stuck on these broken systems. We had nowhere else to go. There is just no plan B. There is only one Earth. With this paper, we hope that we can raise the need to act on this right now. There's an urgency to act on this very fast. We have documented that as early as 2020 in tropical regions, 2047 on average will be the time in which the Earth is likely to face unprecedented climates that will have massive biological and social implications. If you think about this, this is not really that far into the future. This is just 34 years from now. Right now, I'm 38 years old. In 34 years, I will be 72. So there it goes, Camilo. That's my present to you. Enjoy the weather. That is kind of the legacy that we are leaving for ourselves and our children into the future. I truly hope that we can change the situation and we can act right now. It would be pretty sad if we don't. With that, I thank you very much. And for those that are freezing in the South Pole with the penguins, please have a warm regard from Hawaii. Most likely you are going to have warm weather there very soon as well. Thank you. I finished by saying that it was a great experience doing this project. We spent a lot of time together. My wife actually was thinking that I was probably having an affair because every night I was showing up at home at 3 in the morning. Hey, honey, I was just teaching class. So there was a lot of work, and of course this couldn't have happened if we didn't have such a great body of students to dedicate their times to this. We also had great moments of enjoyment on these things. One of them, for instance, just to tell you one of them, one day after we finished the draft, when we were drafting the paper, add the cover letter to the editor from Nature, that was how it was. We were saying how important this paper is, and we wrote a sentence there saying that this paper is very important and relevant right now. And we use a word that is called in lieu.
This is after many hours.
Many hours. It was like 3 in the morning already. And we wrote, this paper is very important in lieu of the IPCC report. And that's how we wrote it. It was there. And one day, one of our colleagues, one of the students came in, and he read that thing, and he was, something doesn't sound right on this thing. It turns out that in lieu, we thought that it was a pretty nice word. In lieu sounds like in light of, you know. It turns out that in lieu means instead of. So there it was. There we were, writing a cover letter to the editor from Nature saying, hey, here we had a very important paper instead of that IPCC report. So we couldn't stop laughing of that kind of situations there. And of course, there were many other moments that were pretty good. I don't think we came across any massive obstacle there, but it was great. With that, I thank you very much for listening. Thank you. All right, guys.